Hi, I'm having the question on our screen, and the question says, what's the equilibrium constant of esterification reaction? Now, before we solve this question, we must first of all ask ourselves what is chemical equilibrium, when is a reaction said to be at equilibrium, do you understand? And what is an esterification reaction? Now, before I answer that question, let's try to explain chemical what? Equilibrium. Now, equilibrium, just like in physics, we do equilibrium position, all this principle of moment. Do you understand? So they'll just keep ruler on a knife edge. They'll ask you to balance it. Now, for you to balance it, you must find the point where the something will be balanced. So a reaction in chemistry, a reaction is said to be at equilibrium when the rate of forward reaction is equal to the rate of what? Backward reaction. Now, in one of my videos, I've done rate of a reaction. Now, I've mentioned rate of forward reaction. I've equally mentioned rate of a backward what? Reaction, right? So this means that for us to be talking about chemical equilibrium, we must have a reaction called a reversible reaction. We must have a reaction called what? A reversible reaction. Now, I will ask you, when is a reaction said to be reversible? Now, a reaction is reversible if the reaction can occur in the forward reaction, in the forward process, and it can equally occur in the backward process. So, for instance, if I have A reacting with what? B. Now, this is the symbol used to denote the reversible, that the reaction is reversible. So I have, they will give C and D. So whenever you see this, the forward reaction and the backward reaction is a reversible, it means what? A reversible what? Reaction. Now, for you to say that this reaction is at equilibrium, it means that the rate of forward reaction, the rate at which the forward reaction occurs, is equals to what? The rate at which what? The backward reaction will occur. So this rate of forward reaction must equals what? Rate of what? Backward what? Reaction. Does it make sense? Now, in that question, they asked us about equilibrium what? Constant. Now, we have to derive the formula for equilibrium constant. Does it make sense? Now, since we want to talk about the equilibrium constant, we have to define the or state the equilibrium law. Now, the equilibrium law states that the rate of a what? A reaction is directly proportional to the concentration of the active masses present in that reaction. Now, I repeat, equilibrium law states that the rate of a reaction is directly proportional to the concentration of the active masses present, the one you are considering. Now, if I want to consider the rate, the equilibrium law, they are based on the forward reaction. Now, the forward reaction is this A and B. Now, listen up. So it means that rate of forward reaction is directly proportional. What's the active masses in the forward reaction? They are A and what? B. Now we just do it A times B. Does it make sense? Now, from mathematics, if we remove this proportionality sign, we have that R subscript F is equals K A times B. Does it make sense? So this is for forward reaction. Now, what will it be for backward reaction? In the backward reaction, we have rate of backward reaction is directly proportional, from the equilibrium law again, is directly proportional to the active masses present. Now, what are the active masses? The backward reaction will proceed in this way. Now, the active masses are C and what? D. So it's directly proportional to C times D. Does it make sense? So if I remove the proportionality sign, I have that RB is equals what? Is equals K C times what? D. Now let's try this K. Now let's try to put something. Let's say this for forward reaction. This is the rate constant. Now this one, that's rate constant for what? Backward reaction. Let's just indicate the B's. Does it make sense? So rate of forward reaction is directly proportional to the active masses present. Does it make sense? Now, for mathematics, we put this is rate of forward reaction. Now, this is what? The rate constant for forward reaction. Rate of backward reaction. The rate constant for what? Backward what? Reaction. I'm trying to bring out the equilibrium constant for this reaction to derive it. Now, I said earlier that for a reaction to be at equilibrium, that RF is equals RB, that the rate of the forward reaction must be equals to the rate of the backward reaction. The rate at which the reactant form the product must be equals to the rate at which the product form the what? The reactant. That's what it entails. Does it make sense? So now I'm having that RF is equals RB. What do I need? Since RF is equals this, it means that this must be equals this. RF is equals this, right? So this must be equals this. So I have that KF times AB, right? Will be equals what? KB times C times CD. Does it make sense? Now these are the rate constant. Let's make the rate constant to come together. If you ever try to make the rate constant to come together, what do? It means that we have something of this order, KF all over K what? B. What will it be? It will be equals C times D all over A times B. Now I will explain. If you ever try to cross multiply this thing, will it give the same thing? Now if you cross multiply this will times this, right? So this will times this. Does it make sense? So this will times this will times this. So it means that this is equals this. So you have KF over this is equals this over this. So what am I seeing here? I'm seeing that the rate constant for forward reaction all over the rate constant for backward reaction is equals to the active masses for what? Backward reaction all over active masses for what? Forward reaction. Very good. Now, this rate constant for forward reaction over rate constant for backward reaction, it is both of them, KF over KB, can be denoted as the KC. Now, this KC is what we are looking for, which is the equilibrium what? Constant. It is the equilibrium constant. Does it make sense? It is the equilibrium constant. Now, whenever you ask to find the equilibrium constant, what do? You take the what? The product that the active masses in the product, their concentration all over the active masses of the what? Reactant. You take them. Now, listen up. We equally take their whole numbers, are the coefficients. For instance, if I have a reaction like this, if I have a reaction G reacted with H, and it is reversible to give me H, to give me P and what? Q. Now, if I have 2 here and I have 3 here, they ask you, what is the rate constant? The rate constant from the formula, we've seen that the rate constant, this is for the product, that the concentration of the product for this one, all over the concentration of the what? The reactants, right? So I'll take, what are the products? The products are this. So it means P times what? Q, right? But this P, what's the number of mole, the coefficient? It is 3. So it will be raised to power 3. All over what? It will be all over the what? The reactants, right? So I have G times what? G raised to power 2 times what? H. I hope it makes sense. So this is the equilibrium constant, and I know you understood how I derived it. Does it make sense? So let's now go to the question on our screen. The question says, what is the equilibrium constant in esterification reaction? Now, in esterification reaction, it is the reaction between an alkanol and an alkanoic acid to form an alkanoate, or you say an ester, and it will give water as well. So what have I said? I said that esterification reaction is a reaction between what? An alkanol reacting with an alkanoic acid. An noic what? Acid. Now they'll give what? They'll give let's say the reaction is reversible. They'll give what I've said, ester, that's alkanoate, and what? They equally give what? Water. Now if I ask you what's the equilibrium what? Constant. What will you say? I hope you will say something like ester times water, that's the product over reactant, that's ester times water all over alkanol times alkanoic acid, right? You do that. Now listen up. In equilibrium constant, it is just like a convention. If you're having the equilibrium constant of a liquid, a pure liquid, and a solid is 1. If you have, it asks you, what's the equilibrium constant of this? Now listen up. This is water. It is a pure liquid. Now, therefore, this water, since we said earlier that it will be ester times water all over alkanol times alkanoic acid, the answer should be ester all over alkanol times alkanoic acid. Now, why didn't I put water? It is from the convention I said that the equilibrium constant of a what? Pure liquid of a, and the solid is what? 1. I hope it makes sense. So the answer to the question on our screen says ester all over alkanol plus alkanol, times alkanoic what? Alkanoic acid. We didn't put water because the equilibrium constant of water that's meant to be here is what? 1. Does it make sense? Now, a question can come like this. If I have the thermal decomposition, okay, I'll ask you. Now, please write it down. Write the answer on the comment section or tell me what it will be. So now, if you have the thermal decomposition of calcium carbonate, CaCO3, that's limestone. If you have, when you decompose limestone, if I have CaCO3, if it is decomposed, it will give you calcium oxide and carbon dioxide. Now, if you balance, is it balanced? Yes, it's balanced. Now, please, guys, try to tell me what's the equilibrium constant. Remember, this is solid, and this is gaseous. So what's the equilibrium constant of this reaction? Please write it down in the comment section. Have a nice day, like, comment, share, and follow Kosi's Academy. Bye-bye.